Welcome to the mini crash series, and you're watching Basil's Physics Classroom. Alright, so in the last class we were learning about units and dimensions. We had started with our mini crash series in the last class. Now there's a small change from this class onwards. Today onwards I'll be uploading the videos in two sections, two parts. Okay, a 6 question first part and a 6 question second part. And the questions for your self-practice will be uploaded with the second part. Okay, so be sure to follow the videos and subscribe to the channel for attending the daily mini crash series. Okay, so let's move on to the chapter one-dimensional motion. So the basic idea behind one-dimensional motion you are all very familiar with, I hope so. Right, so let's move on to the first question itself. Right, so the question is on the screen. Two bodies of different masses, MA and MB, are dropped from two different heights A and B. The ratio of the time taken by the two to cover these distances are, and the 4 options are also given there, right? So let's see how to do that. So we have two masses, one is mass MA and the other is mass MB. So this mass MA is dropped from a height of A and this MB is dropped from a height of B. Okay, so the height is different. Now, in one-dimensional motion, we are actually learning about kinematics, in which we do not consider the mass of the object, right? So the question here is ratio of the time taken by the two to cover these distances. Now here, we are actually dropping the two objects. Now when we are dropping a mass, what will be the initial velocity? What is the initial velocity? Initial velocity is equal to 0. When the object is dropped or released or something like that, the initial velocity is equal to 0. Right? So we can actually apply the equation S is equal to ut plus half at square over here. The second equation of motion. Now it is motion under gravity. So instead of A, we'll be using G. So based on this, we'll be obtaining a relation like this. Time is equal to root of 2h by g. So as you can see here, time does not depend on the mass of the object. Irrespective of the mass of the object, the time depends only on the height over there. Now g will be the same, we know that, right? Now since the height is not that huge or anything, we won't be considering the variation of acceleration due to gravity with respect to height or anything. So here we can write from this equation t is proportional to root h, right? So we can write t1 or ta by tb will be equal to, what is the height in case of ma? It's a. So root of a by, what is the height in case of mb? It is b. Or the answer is root a is to root b. So what is the option? So the option for the question is option C. This is given over there. Root a is to root b is the answer. Is it clear? So here we are making use of the equation for motion and we are solving this. So remember that the time does not depend on the mass. Okay? Clear? Right? So let's move on to the second question. So you can see the second question displayed on the screen right now. And there it is. Second question. A body dropped from the top of a tower fall through 60 meters during the last 2 seconds of its fall. The height of the tower is 95 meter. Options are 95 meter, 60 meter, 80 meter and 90 meter. So we are supposed to find what is the height of the tower, right? So let's write down what is given in the question. Let's draw a small figure also. So a body is dropped from a tower. It falls through 60 meters during the last 2 seconds. So look at the board, everyone. So the body is dropped from a certain height, h. You don't know what is the height. We are supposed to find that, right? Let the time taken be t. The total time taken is t. They're saying that to travel in the last 2 seconds, 60 meters is traveled. The last 60 meters. So this is 60 meter. The time taken to travel is 2 seconds, right? Now, if the total time is t seconds and the time taken to travel this much distance is 2 seconds, what will be the time taken to travel this much? It will be total is t, this much is 2 seconds, means this will be what? T minus 2 seconds. Clear? That will be t minus 2 seconds, and let that height be h dash. That height is actually what? H dash. Okay. So 60 meter in a time of 2 seconds, t minus 2 seconds, it is covering a height of h dash. Okay. So we are supposed to find out the height of the tower, right? So we have to write two equations over here. One, we are taking this portion first, this t minus 2 portion first. Here I can write h dash is equal to half g t minus 2 the whole square. Which equation are we using here? Which equation? S is equal to ut plus half at square. Now again the ball is dropped. It is mentioned in the question. Like in the previous question, since it is dropped, initial velocity will be what? 0. Right? No doubts there, right? So now, here first equation is this. H dash is equal to half into g t minus 2 the whole square. Now let's consider the full journey now. From top to the bottom. What is the height I have taken? H. Right? So H will be equal to what? Half g t square. We are considering the full journey in time t to the height h. Okay. And this is equation number 2. Now in the question it is given that from the figure itself it is very clear that h minus h dash. H minus h dash will be equal to what? 60 meter. Clear? H minus h dash will be equal to 60 meter. So h minus h dash is equal to 60 meter. So from equation 1 and 2 we can write what is h dash and h. H is half g t square minus what is h dash. I'm actually gonna take the a minus b whole square formula here and write it. Half g t minus 2 the whole square. That will be half g t square. Okay, half g t square minus half g 40, okay, plus half g into 4, right? So half gt square and half gt square, and this is equal to what? 60, right? So half gt square and half gt minus half gt square will go. So what is remaining? So g is equal to 10. I'm taking the value of g as 10. So you will be getting this as 10 by 2, that will be 5. 5 was a 20, right? So 20t, 10 by 2, 5 was a 20, minus 20 is equal to 60. So when you open the bracket, we are getting like this. So from here, what do you get? T is equal to 20 to the other side, 80 by 20, thus t is equal to 4. So we obtain the value for time. The time taken by the object to go from here to here. But that is not the question, right? What is the question? We are supposed to find out the height, right? H. How do you find the height? Substitute this value of t in this equation, in the second equation. So what do you get? Substitute the value of t in the second equation. We get h is equal to half g into t square. 4 4s are 16. So that will be equal to what? 8g. That will be equal to 8g, or that is equal to 80 meters. That's equal to 80 meters. And what is the answer? Answer is option C. Okay. So remember the steps. We are framing two equations over there. Then h minus h dash value is given there. So whenever you solve this question, please make sure that you draw a small figure. So using that small figure, you can solve it easily. Okay. Right. So let's move on to the next question now. And the third question is there on the board. Question number 3. A body A starts from rest with an acceleration a1. After 2 seconds, another body B starts from rest with an acceleration a2. If they travel equal distance on the 5th second after the start of A, that is very important, that point, then the ratio of A1 is to A2. So 5th second, they're asking you. nth second. So what is the formula for the distance traveled in the nth second? Sn is equal to u plus a into n minus 1 by 2, or you can also write as u plus a by 2 into 2n minus 1, the same thing, right? So for the first object, they are saying that in the 5th second, so first object, S5, I want A, the first object, that's equal to, starting from rest, u equal to 0, since it is starting from rest. So A1 into 5th second, right? 5 minus 1 by 2, that is equal to, 5 is a 10 minus 1, 9. So A1 into 9 by 2. A1 into 9 by 2. Now for the second object, it is said that they travel equal distance in the 5th second after the start of A. In the question is specifically mentioned that the second object is starting only after 2 seconds, right? After A started, the second object is starting only after 2 seconds. So, when A has traveled 5 seconds, what is the actual distance that was traveled by the B? What is the actual time that has been traveled by B? It is actually 3 seconds. Is the point clear? A travels in 5 seconds, he is able to travel, but at the same time, B is traveling only for now what? 3 seconds. So, this should correspond to the distance traveled by B in the 3rd second, right? So, S3B should be equal to A2 into 3rd second, right? 5, 3 minus 1 by 2, that will be A2 into 5 by 2. Now they are saying that this distance and this distance is equal. So take the ratio. So taking the ratio, what do you get? This and this gets cancelled out. So you're getting A1 by A2 is equal to what? Is equal to 5 by 9. And that is option A. So I repeat once again. So for the first body, we are finding the distance traveled by the first body in the 5th second. But that 5th second is actually corresponding to the 3rd second of the second body. Why? Because the second body is starting its journey only after 2 seconds. Understood? So I hope the point is clear. So in case you have any doubts, do comment below. I'll be ready to clarify it once again. Okay. Alright. So that is about the 3 questions. Then we are moving on to the next one and the 4th question. 4th question is on the screen now. And it's again a previous question which has actually appeared in both JEE as well as NEET entrance examination. Okay, so the question number 4. Preeti reached the metro station and found that the escalator was not moving. She walked up the stationary escalator in time t. On other days, if she remains stationary in the moving escalator, then the escalator takes her up in a time t2. The time taken by her to walk up the moving escalator will be. So 3 situations are given to you, right? And there is an escalator also. So what is happening? Let's see. So in the first day, what is happening? Preeti. So let's take the velocity of Preeti as u and the velocity of escalator as v. Fine. In the first day, escalator is not moving, only Preeti is walking up. So, but in all the cases, let me ask you, the distance traveled along the escalator is the same, right? Distance is the same, no doubts there. So we can write, in the first day, the time taken by Preeti, time is equal to distance by velocity, or velocity is equal to distance by time. So, first day, u is equal to d by t1, first day. Okay, speed is equal to distance by time formula, right? In the second day, Preeti is standing still. What is moving? Escalator is moving. So in the second day, we can write v equal to d by t2. Okay, and the third day, what is happening? Preeti is moving and the escalator is moving. So in the third day, v plus u equal to d by t. V plus u is equal to d by t in the third day, right? So, 3 equations we are having. So we are supposed to find T in terms of T1 and T2, right? So how do you do it? We know what is V already. We already know what is U from here. Just substitute and simplify. So that will be D by T2 plus D by T1 is equal to D by T. D gets cancelled out. So what is remaining? 1 by T2 plus 1 by T1 is equal to 1 by T. Now cross multiply and simplify, you're getting T is equal to T1 plus T2 by T1 T2. So T1 T2 divided by T1 plus T2. And you can actually by heart this as a final expression also, because if you're getting a value, if a time value is actually provided to you or given to you, you can actually make use of this equation to arrive at the final answer. Okay? So this is actually a very simple question, but like I told you, it is a repeated previous year question, both in the JEE point of view and in the NEET point of view. So take special care of it and don't forget how to do this. Okay, right. So shall we move to the next one? Right. So the next question is there on the screen. Let me take the question. The next question is, a point initially at rest moves along x-axis. Its acceleration varies with time as a is equal to 6t plus 5 meter per second square. If it starts from origin, the distance covered in 2 seconds is distance covered in 2 seconds. Okay. So how do you find the distance covered in 2 seconds? So what is given to you? Acceleration, which is equal to 6t plus 5 meter per second square, right? Now, acceleration is given. If acceleration is known, how do you find velocity? Take the integral of this, right? So what are you given to take the integral? Integral a dt. That will be corresponding to what? 6t integral will be what? 6t square by 2. 5 integral will be what? 5t. Clear? Now, it is starting from the origin, so you don't have to worry about the constant term there. Now we are getting velocity. We are supposed to find the distance, right? So we take the integral of this quantity once again. So distance s will be equal to integral v dt. So you take the integral for that, you get 6 by 2. This is actually 3t square. Integral of 3t square will be what? 3t square by, 3t cube by 3. 5t integral will be what? 5t square by 2. 5t square by 2. Okay, I'm assuming that you know how to take the integration. Okay, so that's why I'm not showing you the method or anything there. Alright, so from 3 and 3 gets cancelled. So s is equal to t cube plus 5 by 2 t square. Now the value of t is also given there, right? At t is equal to 2 seconds, they're asking you. 2 seconds. So how do you get the answer? This is equal to t cube. So 2 cube, 8 plus 5 by 2. T square, 2 into 4. 2. 4 5 is a 10 and the answer is 18 meter. So the answer is 18 meter, and which is option number 2. So the answer is 18 meter. So we are given acceleration. We are taking the integral to get velocity. Again we are taking the integral to get displacement. And finally we are finding what is distance traveled at 2 seconds. That is corresponding to 18 meter. Okay. So I guess that's a very simple question, right? You'll be able to tackle it. But this is again a previous question. Okay. So it may appear to be simple, but if you forget any of the steps or any of the terms, if you forget to put it, then it gets complicated. Right. So let's move on to the next one now. And the next question is around the board. So the next question is, a 150 meter long train is moving to north at a speed of 10 meter per second. A parrot flying towards the south with a speed of 5 meter per second crosses the train. The time taken by the parrot to cross the train would be. So a 150 meter long train is there. What is the length of the train? 150 meter long, right? So it is moving with the speed. What is the velocity of the train? Speed is 10 meter per second. Parrot is flying towards south. So train towards north, parrot towards south, which means they are moving in the opposite direction, right? So this is velocity of the parrot. They are moving in the opposite direction. Now it crosses the train. Okay, fine. The parrot is able to cross the train. The time taken by the parrot to cross the train, they're asking. So now, here we'll have to apply the concept of relative velocity. In one-dimensional motion, the concept of relative velocity is actually very simple. The relative velocity in two-dimensional motion will be dealing in the next class, and that you have to take special care because that's a bit confusing. But it's again a simple topic. Okay, so here in the one-dimensional motion, when two objects are moving in the same direction means, we will normally write the relative velocity component. Relative velocity of A with respect to B will be VA minus VB. Relative velocity of A with respect to V will be VA minus VB. And if they are moving in the opposite direction, then VAB will be equal to VA plus VB. VA plus VB. Same direction, VA minus VB, opposite VA plus VB. Okay. Right. Now, let's see how to solve this question. Now, here they are moving in the opposite direction, which means the relative velocity of the train with respect to the parrot will be equal to 10 plus 5 or 15 meter per second. Right? So now we can find the time taken. Time is equal to distance by velocity or the displacement by velocity. So 150 divided by velocity, relative velocity is 15, that will be 10 seconds. So the answer is what? 10 seconds. Okay. Now there is a small change for this relative velocity concept when we go on to boat river problems. Okay, that we can discuss in a later class. Right. So time is equal to 10 seconds. So right now just remember this, they're moving in the opposite directions and we add up, so we get 15 and we're getting time as 10 seconds. Okay, so I hope this is clear. Till this question I hope it is clear for you. We'll be winding up the session and please watch the next video for the second part of motion one dimension. Alright, so till we meet again, thank you. And please do subscribe to the channel Basics Physics Classroom for further updates.